Today we're going to look at the relationship between differentiability and continuity. So we're going to take a look at a few different cases. And our first case, we're going to consider the absolute value. So let's see. That looks something like this. Now we know that f is continuous at x equals 0. We know that visually because we can draw this function without lifting our pencil, and we also know that because the limit is 0, the function value is 0, which means that the limit and the function value are equal. So we definitely have continuity here, but we do not have differentiability. Now we'll see that if we consider the derivative from the left. The derivative from the left, and we'll compare that to the derivative from the right. So here, the slopes on the left side, so the derivatives on the left, would all be equal to -1. But the derivative on the right, all the slopes on the right side, would be equal to +1. Since the derivative from the left is not equal to the derivative from the right, we can say that f is not differentiable at x equals 0. So we have continuity, but not differentiability, and that's going to happen whenever you see a sharp turn. So you may see that with a cusp or something that's piecewise, but if your function is not smooth, you're not going to have a derivative at that point. And this is the next case we're going to look at. This is the graph of x to the 1/3. And we're still looking at where x is equal to 0. Now notice that when x is equal to 0, that our function is continuous at x equals 0. But what happens is, as we draw tangent lines from the left, notice that they're getting more and more vertical. That also happens from the right. If we draw tangent lines from the right, our tangent lines are getting more and more vertical. And what happens right here is we draw a vertical tangent line. So when x is equal to 0, we do have a tangent line. It's vertical, but the slope of that tangent line is undefined. Vertical lines do not have slope. The slope of this tangent line is undefined. So if the slope is undefined, then the derivative is as well. So f is continuous at x equals 0, but f is not differentiable at x equals 0. And that's going to happen whenever you have a vertical tangent line. So we've seen cases where the function is continuous at a point but not differentiable at that point. But what happens if f is not continuous? Well, we have a few different types of discontinuities. We have an infinite discontinuity. We have a jump discontinuity. And we have a removable discontinuity. So for all three of these, f is not continuous at x equals c. But f is also not differentiable at x equals c, and we're going to consider this visually. For this one, there's no function at x equals c. If there's no function, there's no way for us to draw a tangent line to the function. The same thing happens here. At x equals c, there's no function to draw a tangent line. And if the function did exist, we can't draw a tangent line to it because there's no function to the left or to the right of this point here. And the same is true in the middle. You can think about the question, where would I draw a tangent line at x equals c? The function is defined, but there's no function to the left of this point, and there's no function at this point. So we can say if f is not continuous at x equals c, then f is not differentiable at x equals c. Now this statement is true, which means that its contrapositive is true. The contrapositive says that if f is differentiable at x equals c, then f is continuous at x equals c. So that's our relationship, and we can think of it either way because both of these statements are true. So if f is differentiable at a point, we know that f must be continuous at that point. We know that if f is not continuous, then f is not differentiable. Okay, here is our summary. A function is not differentiable at x equals c if f is not continuous. Right? We know that if a function is differentiable, then the function is continuous. I'm going to write differentiability implies continuity. We know that the function is not differentiable if f has a vertical tangent line. And we know that the function is not differentiable if the derivative from the left is not equal to the derivative from the right. That's our sharp turn, or where the function is not smooth.